In the last video, we took a look at this idea that a squared plus b squared equals c squared, and turns out it's what we call the Pythagorean Theorem, a way to show a relationship between the three sides of any right triangle. Now, once again, don't forget, these findings only work for right triangles. One of the corners has to be 90 degrees. Now, one other thing we also need to know is that, well, as far as a squared, b squared, and c squared, which side's which? Okay, that's really important. So, turns out that what we do is we actually label the sides. That first, this side is what's called the hypotenuse. And there's two ways to figure out which side the hypotenuse is. One way is to say the side opposite the right triangle, meaning if I look at my right triangle, it's the side across from the right triangle and doesn't actually touch that 90-degree corner. Another way, if the measurements are given, is that it's also the longest side. Of these three, the hypotenuse will always turn out to be the longest one. Now, what about these other two sides? Well, those are what are called the legs. Now, the legs are the sides adjacent or touching the 90-degree corner. So this is one of the legs here, and this is one of the legs here. And so to keep track of which one's which, the hypotenuse is always labeled C. So this side here, the hypotenuse, that would have measurement C. And then the legs are A and B. Now, these are interchangeable, so it wouldn't make a difference if we were to label this side A and this side B, or vice versa. Make this side B and this side A. So those are the only two that you can switch back and forth, but the most important thing is that measurement side C has to be the hypotenuse. And so what we come up with is that for a squared, b squared, and c squared, this theorem works for any right triangle where the measurements are, where a and b, the measurements are the legs, and c is the measurement of the hypotenuse. That way we can keep track of which side's which and which numbers go into our theorem. Alright, so let's try this out. Here's our right triangle, and we need to figure out this missing side. So first off, we should notice that what they've given us are the two legs. These are A and B. And it doesn't matter which one's which, so I'll put A here, I'll put B there. We could have easily interchanged those two because it doesn't make a difference. But the side missing, the side opposite our right angle, is C, the hypotenuse. So now I can plug it into our formula. A squared plus B squared equals C squared. So here I just need to simplify and then solve. In this case, simplifying means doing the exponent. 24 times 24 is 576, and 7 squared would be 49. Alright, and then we can simplify that further. 576 plus 49 turns out to be 625. Alright, so we've cleaned that up as much as we can, but now we actually have to solve the equation. We have to solve for C. And as we've learned, that the opposite of squaring a number is to square root it. So we'll undo the square by square rooting, and this will give me my measurement of C, and the square root of 625 turns out to be 25. So if all these measurements hold true, then our missing measurement is 25. Okay, and so that's how we use the Pythagorean theorem to find missing sides of a right triangle. Let's try another one. Now, just to change it up a little bit, what I'm going to do here is we can see they've given us the legs, but to show that it just doesn't matter, unlike this last one, where we made this A and this B, I'm just going to switch it because it doesn't matter. Let's make this one B, this one A, but definitely this one, this still has to be C. It's the side opposite the right angle, and it's going to end up being the longest side. Which is a nice check too. If we get an answer that's less than 6 or 3, and it's not the longest side, then we did something wrong. Alright, so A squared plus B squared equals C squared. Alright, so now simplify and solve. Simplifying by doing our exponents, which is 9 plus 36 equals C squared. 9 plus 36, that's 25. And then we have to solve it. solve for c by getting rid of the square. We square root. Squares and square roots cancel. And so c turns out to be 5. So 5 units long for that. All right, which brings us to our last example. But in the last example, we're going to put a little twist on it. We're going to ask the question, what if one of the legs is missing rather than the hypotenuse? Well, how's that going to change our work? So if I go through here and label this as A, label this as B, and this one is C, notice how the hypotenuse is given, but what's missing is leg B. Well, we can still use the same Pythagorean theorem. We can do 12 squared plus, and now in this case, B squared, since we don't know what it is, equals 20 squared. So, still, simplify and solve. 12 to the second power is 144 plus b squared equals 400. Now, as far as simplifying and cleaning things up, that's all I can do, because now it's all about getting b by itself. So if I think about solving an equation and how order of operations plays out here, they've got b squared plus 144. So I'm going to undo things in reverse order. I'm going to start off by subtracting 144. And what I do to one side, do it to the other. And so here these cancel. And I get b squared equals, what is that going to be? 256. Alright, so now we undo the square by square rooting once again. So I get b equals, and I believe this is 16. So 16 units for b. Okay, so notice as far as the Pythagorean theorem, it's still a squared plus b squared equals c squared. What has changed since the leg was missing was some of our work. We still simplified, but then for solving, it just added a few more steps. We had to get rid of the 144 by subtracting, and then we had to square root to get b. But it's not much harder than trying to find the hypotenuse. It's all the same. It uses the same theorem. It's just a matter of what our work looks like towards the end. All right, so take this understanding of the Pythagorean theorem, a squared plus b squared equals c squared, apply it to your assignment, and good luck.